Alrighty then. Time to get started. All right. Let's see here. I'm just getting things set up here real quick. Bear with me. Un minuto, por favor. Okay. Alrighty then. All right. So, all right. We left off on ZyBooks 3.4 yesterday. So we'll continue on from here, and then we'll go in order. I'll probably finish the rest of 3 point here of variables and expressions here, and then go back to the practice test, which I believe we got to. Uh, I feel like we got to either 29.5 or 29.6, something like that. So we'll start maybe on like 25 or 29.5 or 20. Either way, we'll go back and do the practice tests. I haven't seen anybody want to do anything different. So what I'll do is I'll just continue like this until somebody suggests that I go in a different order, if it would be helpful if I go through something else with them. But like I mentioned before, I'm learning, you're learning, we're all learning together. This is like me kind of talking out loud to myself and learning, and at the same time, hopefully the way I learn is, you guys as well. But I have my chat open on my screen, so that way if anybody has any thing they'd like to review or have questions or want me to go back to something else and go through that with them, then I'll be happy to pause where I'm at and then go from there. Otherwise, here we go. Oh, one sec though. I think the music in my ear is too loud, so I'm going to turn it down just a sec. There we go. All right. All right. So, and then also I mentioned if there was something I was doing you don't like if I'm reading out loud and you're like, hey, don't read out loud, then let me know. um, Floating point numbers and scientific notations. A floating point number is a real number like 98.6, 0.001, or negative 666.667. The term floating point refers to the decimal point appearing anywhere floating in the number. Thus, float is a data type or floating point numbers. A floating point literal is written with the fractional part, even if that fraction is zero, as in 1.0, 0.1, I mean 0.0 or 99. So okay, I mean it's basically explaining what the float means. So it's a number with a decimal. It's pretty much what it comes down to. A program uses float type variables. The below program reads in a floating point value from a user and calculates the time to drive and fly the distance. Note the use of the built-in function float when reading the input to convert the input string into a float. Note that print handles floating point numbers straightforwardly. So here we can see that enter a distance in miles. So this string is assigned to miles, and then hours to fly is assigned to miles. So enter the distance. So whatever miles they enter here divided by 500.0, which is a float. Hours to drive is assigned with miles divided by 60. And then it looks like it prints out miles. So it'll print out the whatever the math is for these, and then say miles would take. So we can see it on this side where it's like 0.9 miles hours to fly, Same thing, so all these three prints are printing out these variables and what value they hold. Enter distance miles. So here it shows an example of entering 1800, and these are the results of that. Scientific notation is useful for representing floating point numbers that are much greater than or much less than 0, such as 6.0 times 10. I think you say that 10 to the power 23. I think that's how you say that. A floating point literal using scientific notation is written using the e preceding the power of 10 exponents, as in 6.02e23. To represent 6.02 times 10 to the power 23, the e stands for exponent. So 6.02e23. The e stands for exponent. Likewise, 0.001 is 1x 10 minus 3. So it can be written as 1.0 e minus 3. Type 1.0 e. Does that say minus? Yeah, that's minus. As a floating point literal, but not using scientific notation, with a single digit before and 4 digits after the decimal point. Hold on, let me reread that again. Type 1.00 e minus 4, negative 4 actually, as a floating point literal, but not as a scientific notation, with a single digit before and 4 digits after. So is it saying that it wants me to do 1.0 minus or negative 4, or 10 negative 4? Is that what it's wanting me to do? Type as a floating point literal, but not using scientific notation, with a single digit before and 4 digits after. So 1, 2, 3, 4 after the decimal point. I'll be honest with you, I am not too sure how it's wanting me to write it, so I'm gonna guess, and if it's wrong, I'm gonna find out why. Before and after decimal point. Okay, well, let's, because it almost sounds like it wants me to take out this x here and write it like that or something like that. So that's wrong. So let's see if it wants me to do it this way. That's wrong. So this is why I do this, is because I'm learning, you're learning. So this is why I do this out loud, because it helps me learn, and hopefully it helps you learn too. So forgive me if I don't know all the answers. We learn it together. Type 1.0 e negative 4 as a floating point literal. And according to up here, like 6.02 e23 to represent. I mean, so is it just literally wanting me to repeat what it's saying? No. All right, so let's check this out. So 0.001. So I guess the E4 shifts the decimals point 4 places to the left. 1, 2, 3, 4. Okay, so does that mean let's try this again. Type 7.2 e -4 as a floating point literal without center. So is that saying that it wants it to be like 0.123, not 17, but like, so the 4 shifts it over 4, where 1, 2, 3, 4. So the decimal goes there. I guess my confusion is where the 7.2 would go. So let's see if it has an example up here. So it doesn't really show an example here. It shows this. I'm going to try this. I feel like it's wrong. So answer is nearest correct. See how to below. So your answer, expected answer 7.2. Okay, so I had a feeling that that 2 would go somewhere, but and then 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So I wonder why it says that the E negative 4 shifts the decimal to the point 4 places, right? So the E shifts the decimal point 4 places to the left, which, okay, but 1, 2, 3, 4. 1, 2, 3, 4. I mean, it doesn't seem like it shifts it 4 to the left. Is it 4 from the 7? Oh, because it was 7.2, so the decimal started here and then went 1, 1, 2, 3, 4. That makes more sense. That makes a lot more sense. So because on this one, the 1.0, so whoops, 0.1231. So the decimal actually started here and then went over 1, 2, 3, 4. So that makes sense. But that 0 isn't added. The 72 is. Okay. Type 540 million as a floating point literal using scientific notation with a single digit before and after the decimal point. So is that like 5.4 exponents exponent -6, maybe, to move the decimal over. So the way I'm thinking of it is 54, 1, 2, 3, 1, 2, 3. The way I'm thinking of it is that the decimal starts here, and then we move over 1, 2, 3, 4, 5, 6, 7, 8, 8. So is it 8? Let's find out. I might be doing it wrong. Actually, I think I am doing it wrong. So close. So answer is near is correct. So your answer. Okay. So it is actually 5.4E8. So let's fix that, and then it'll tell us why. Because up here, it says shifts it to the left, but this may not. The way this is written may not shift it to the left. Oh, whoops! I didn't correct it, dummy. Okay. Represents 5.4 10 to the power of 8. And is that because I'm just going to look something up real quick here. I want to do the math here. And is it because you, yeah, okay, that's because it does the math 5 times. So I guess you have to kind of think in your head, okay, what what times what will equal 54 million. So in this case, 5.4 um, times 10 to the power of 8 is what uh, equals 540 million. So this is going to be interesting, an interesting subject here. Type as a floating point literal scientific notation. Okay. Now, from what we've done up here, suggests that we are going to do that here as well. And if we actually write this out, 0 0.1, 2, 3, 4, 5, 1. Is that 5? 1, 2, 3, 4, 5, 1. Yeah. Okay. So I have a feeling it's going to be like this: 0.1 or 0.0, right? And then 1, 2, 3, 4, 5, 6 over 6. So is it going to be 1.0 e minus 6 or negative 6? Just kind of basing it off of what we did up here. 1, 2, 3, 4, 5, 6. I'm going to try that and see if that works. So why did I put 3 there? I don't know why I put 3 there. So I would have had it right if I didn't put the 3 there. Oh, I meant to put E and I accidentally typed 3. Dummy. So I did have it right. I just pressed the stupid wrong button. All right. Type 623.596 as a floating literal using scientific notation. Okay. So I'm going to, well, this is a decimal place, and this was not a decimal place. So kind of based off what we were doing up here, I want to do the same thing. So up here, I am just thinking here, 1, 2, 3, because is it, oh shoot, man. Okay. Let's try something here. This one's, man, this one's a little bit of a difficult subject for me, I guess. I don't, I'm struggling with, I'm assuming this is simple math. So up here, like 98, literal is written with the fractional part, even if that fraction is 0, as in 1.0, 0.99.0. So, and this wants it to be a literal. So it's wanting something like, like 623 point, I mean, does it want the whole thing like this and then like that? Is it wanting it something like that? No, it's not. Or -3. No, it's not. Or is it um, is it, no, that's, I have it. I think I'm gonna have the answer told to me. Yeah. Okay, so what did it do here? The E2 indicates that shifting the decimal 2 places to the right will yield the original number. Meaning, so 6.23596 E2. So it's saying if it shifts the original decimal point to 1, 2, 2 decimals, okay, so it does provide the correct number. But my question is why did it change to 6.23 in the first place versus 623.596? Like, why did it even shift in the first place? Indicates that shifting the decimal to the place right. You know what I mean? Like, I we may come back to this only because I don't want to spend too much time on it. I know I got to understand it, but I don't want to spend too much time on it either. I'm going to have to look up, I'm going to actually make a note to look up exponents, and maybe I can come back and do a live once I've learned what to do and explain it here as well. So these are scientific notations. Scientific notations. And it was called what? Floating point literal. Floating point literal. I could probably find more information on like W3 schools or YouTube or something here. So let's go on so we don't spend too much time on this part here. Energy to mass conversion. This is going to be fun. Albert Einstein's equation E equals mc squared is likely the most widely known mathematical formula. The equation describes the mass energy equivalent, which states that the mass amount of matter, m, of a body is directly related to the amount of energy, E, of the body, connected via a constant value, c squared, mc squared, yeah. The speed of light squared. Okay. The scientific of the equation is that matter can be converted to energy, and theoretically energy back to matter. The mass energy equivalence equation can be used to calculate the energy released in nuclear reactions, such as nuclear fission or nuclear fusion, which form the basis of modern technologies like nuclear weapons and nuclear power plants. The following program reads in a mass in kilograms and prints the amount of energy stored in the mass. Also printed are the equivalent numbers of AA batteries and tons of TNT. So let's run it. Oops, I pressed the wrong button, sorry. Oh, it's already ran right here. I think, yeah, it already ran. Total energy released, and it has this long ass number here, joules, which is as much energy as that many AA batteries, that many tons of TNT. That's a shitload. So what is it doing up here? So it looks like it's setting a variable, the speed of light, AA battery variable, assigning it nickel, cadmium, AA batteries. And it looks like it's doing joules per TNT ton. So it's assigning the variables here. It's taking mass kilogram input as a float here. Energy joules. So it is taking a variable and assigning it mass kilogram. So the input times c meters per second. So this one here to the power of 2. That's what this means. E equals mc squared. That's exactly what it's doing here. Total energy. Okay. And then it's just kind of repeating, doing the math and repeating that out to us here, or printing that out to us. Overflow. Float type objects have a limited range of values. Excuse me. That can be represented. For a standard 32-bit installation of Python, the maximum floating point value is approximately 1.8 times 10 to 308. And the minimum positive floating point value is approximately 2.3 times 10 negative 308. Assigning a floating point value outside of this range generates the overflow error. Overflow occurs when a value is too large to be stored in the memory allocated by the interpreter. Example, the program in the figure below tries to store the value 2.0 to the power of looks like 1024, which causes an overflow error. In general, floating point types should be used to represent quantities that are measured, such as distance, temperatures, volumes, and weights. Integer types should be used to represent quantities that are counted, such as numbers, cars, students, cities, hours, and minutes. So, so this one here, oh, okay, so overflow error 34, results too large. Dang, I don't know why I'm all yawning today. Choose the right type of variable to represent each item. The number of cars in a parking lot. It'd be best to use an integer. The current temperature in Celsius. That would be a float. A person's height in centimeters. That would also be actually, is centimeters? No, I think it would be a float still. Yep, okay. The number of hairs on a person's head. That would be an integer because it's a single count. You're not going to have like, I wouldn't think you have like 2.2. I don't know. The average number of kids per household, also an integer. What? The average number of kids per household? You're going to have 2.2 kids, like what, 2 kids and 2 legs? Nobody has exactly 2.2 kids. But the average almost certainly should involve a fraction. Come on. It makes sense and it doesn't make sense. It's stupid. Manipulating floating point output. Some floating point numbers have many digits after the decimal point. Example, irrational numbers. Example, 3.141 blah, 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 blah. And repeating decimals, 4.33333, have an infinite number of digits after the decimal. By default, most programming languages output at least 5 digits after the decimal point. But for many simple programs, this level of detail is not necessary. A common approach is to output floating point numbers with a specific number of digits after the decimal to reduce complexity or produce a certain numerical type. Example, representing currency with 2 digits, so like $2.25. The syntax for outputting the float, my float, with 2 digits after the decimal point is print f string my float. So this right here, when you put this here colon dot point two f, that right there is basically saying to put the decimal point to have at least 2 digits after the decimal point, whether it's a 0, because if you don't put that, and let's say it's a 0, it'll only output 1 0, like 2.0. But let's say it's like 2.00, and you want that 00 to be there, you'd want to put this colon dot 2f after your variable here to make sure that it does add those two. When printing out a certain number of digits after the decimal using print, Python rounds the last output digit, but the floating point value remains the same. Manipulating how numbers are output is discussed in detail elsewhere. But yeah, and this is an F string, by the way. I mentioned that, talk about that a little bit before, because without this, in order to print this out without the F string, you would have to, have several lines or a couple lines. I mean, this is a simple example, but like if you had a long sentence here, like, this number represents my float, blah 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 blah, then you'd want to put it in F string so you have one clean single line of code. All right, let's restart this. The mathematical constant pi is irrational. Pi is floating point number whose digits after the decimal point are infinite and non-repeating. The math module defines the constant pi with the value of pi. Okay, so right there. Though Python does not attempt to output the full value of pi, Python outputs 15 digits after the decimal by default. Print this code here is the same up here. Outputs pi to only 4 because it instead of 0.2 like it does up here, so 2 decimals, it put 4, meaning I want 4 decimals or 4 digits after the decimal, which is showing here 4 digits after the decimal. I wish I can't remember what this is called. I'll look that up, but I can't remember what that was called. But that's what that does. Unwrap string. Which of the following arguments completes print to output 2 digits after the decimal point? That would be, see, so it tries to trick you here. So this point to F is partly correct. It's colon point to F. What is output by print F string 0.125 colon 0.1F? So it only wants 1 digit after the decimal. So we are going to get 0.1. What is output by this thing here? So this is wanting 3 digits after the decimal point. So we would get, this one is interesting because this one's rounded up and this one's not. And I believe you have to use the round function to make it round up. I don't think it will I think it automatically rounds down. So I feel like it's going to be 1.135. So let's find out. No, I'm wrong. Does not truncate the output, but instead rounds the output. So it does round it. Holy shit. Okay. I learned something here. See, this is why we do this together, because we learn together. So it does round it. So outputs, because the third digit after the decimal point is rounded automatically. So I know there's a round function you can use that will do the same thing. You can have it round up, you can have it round down, you can have it round to the nearest tenth, things like that. So that's interesting. So it will automatically round it up, it looks like. I wonder if it was 5.5, I wonder if it would round it, like keep it 5 or round it up. The number of gallons of paint needed to cover a wall is equal to the wall's total area divided by 350.0. The program reads, oh my gosh, I'm telling you, I'm not sure why I'm yawning all day today. The program reads wall area from input, representing a wall's total area. Then the program computes number of gallons as wall area divided by 350. Complete the program. Oh, that's cool. It has examples. Complete the program to output the number of gallons of paint needed to cover the wall, rounded to 5 digits after the decimal point. Okay, so so what do we have? So we have the input of the wall area, and then we have the number of gallons equals the wall area divided by 350, and that would be the number of gallons. And it wants us to complete the program to output the number of gallons rounded to 5 digits. So the way we would do that, I think, or well, yeah, in my head, print. So we're going to put the F string here. And we're going to do, in order, so when you use the F string, just real quick, when you use the F string, if you don't use the F string, you can output the variable like this. Oops. Right? And you just type out the variable and that'll print it out. But when we're using the F string, what you need to do is add the variable within these curly brackets here in order to print it out. And then it said that we want it to be 5 digits, so we'll do 5f point. So you notice that I put colon 0.5f and then the end quotation here. If you don't put that end quotation, it will fail or it'll give you an error. But let's just make sure this is what it's asking for. Oh, okay, so it even shows like a small example here. My float xf outputs. So this looks correct to me. Let's run it. And voila, it does do 2, 4, 5 digits after. Perfect. Any questions to the people who are not? I don't know if people are watching. Oh, it says I've got 2 people watching, so hello. Hopefully it's uh, entertaining or I'm teaching you something or you're learning with me. So if you want to chime in, comment, do whatever, you can. Okay, where are we? The inverse of work input is 1 divided by work input. Is 1 divided by work input. The following program intends to read a floating point value from input and output in the inverse, but the code contains an error when reading from input. Find and fix the error. Example, if the input is 0.470, then the output is the inverse of work equals 1 divided by 0.470 equals 2.128. Okay, let's see. So I can tell you right away that I think I know what's wrong here. So the input looks like it's taking in a decimal number. And if you remember, decimal numbers are actually floats. And this here is saying that it's converting the input to an integer instead of a float. So editing is disabled. You just told me to, oh, I gotta press start, dumbass. Okay, so we want to change the integer into a float input. And I think that was the only thing we needed to correct because everything else looks correct. So let's check it. Boom. Noise. Next level. 1 gram equals 1,000 milligrams. Read weight milligram from input as a float. Okay. Well, that's our first thing there. Then convert weight milligram into weight grams. If input is 11,000, then the output is 11. So it wants us to, so 1 gram, so read weight mgs, milligrams from an input. So we want to create, we want to create, oh, okay, it told us right here as a float. So I was wondering if we need a float or an integer, but it tells us to use a float. So we'll do float input weight milligrams, float, then convert weight milligram into weight grams. if the input is. So is it moving the decimal point 1, 2, 3? It's moving the decimal point over 3, right? Am, do I I'm trying to think. Then convert weight milligrams into I'm trying to think, how do you convert milligrams into grams? Am I sucking at math again? I'm gonna how to convert milligrams into grams. Let's see. So because I don't need, I don't need to be told how to code it. I just need to be told how do you convert it, right? So is it milligrams, the milligrams divided by 1,000? Is that what it is? So like divided by 1, 1, 2, 3, like that. So 1 gram. Oh, I mean, I guess okay. So 1 gram equals 1,000 milligrams. So it would be, right? Let's test it. I think it would be. No, no, why not? So 1 gram is right. So oh, here's an error. Name error. Name weight grams is not defined. What? WEIGHT underscore. You idiot. Okay, so what I did was I did not I did not assign weight to grams anything yet. So we need to do weight grams is the input of weight, whatever the input is for weight milligrams. I'm going to get it wrong again because I misspelt it. Divided by 1,000, right? So we don't want to do it here. Divided by 1,000. So then it will print it out with 3 decimals. So weight, always make sure you're spelling it right because that'll mess you up. So that should be correct now. Okay, perfect. So, and that's, I feel like, messing up is a good thing because it's teaching, I mean, it teaches you a lot more. It teaches you, where you messed up. It teaches you what to correct. It's kind of like, you know, working your little muscle memories. Um, but yeah, so okay. Let's see. So let's go to the next level. Complete the program of output area is man, followed by the value of square area. So if the output is okay, so so it's wanting us to print it out. So we're going to do an F string again, and it says area is, and then we'll do square area. I think that's all it wanted us to do is area is, and then output square area. So let's double check it here. Let's check it. I think that's what it wants. What did I do wrong here? So let's see, this is why we do this. Did I spell it wrong? SQUARE underscore. Yep, I forgot the A. Like I mentioned in the last one, that's because if you misspell it, it's going to be wrong. I thought I double checked it, but I still missed it on both checks. So being a little bit more detail oriented should be a thing as well. Uh, what happened? Oh, did I not? Oh no, I did. Oh, okay. So once again, this comes back to the making sure you're being detail oriented and reading through the instructions, because this tells us that we need it to have we need to have 4 digits after the decimal. So what do we got to do? Colon dot. We want 4 digits after the decimal is what it tells us, and I did not do that. Let me make sure before I click check again. 4 digits after the decimal point. Check the program and output area is followed by the value of square area, 4 digits. So it should be right this time. Okay. So yeah, so I was just messing up the little details that should matter is what I was doing. Complete the program to output area is. Oh, did I not click next level? I thought I did. Okay. Complete the program as follows. Read triangle base and triangle height from input as floats respectively. So we'll start with number 1 here. Triangle, excuse me. Okay. So triangle base and oops, triangle base. So it wants 2 variables, triangle base and triangle height, right? And it wants to have that 2 as reading it, so input, and it wants it as input as a float. So we will take an input as a float. Okay. Compute triangle area using the formula. Triangle area is equal to so is it saying, is that 1.0 divided by 2.0 times triangle base times triangle, no caps on the T, triangle height, right? Now with this one, following orders of operation, it should calculate these two and then multiply that answer times triangle base, and then try that answer times triangle height. So I shouldn't have to put any uh, any what do you call this, brackets, not bracket, whatever they're called. You wouldn't have to put those there because it's just going to follow order of operation from left to right because it's division and multiplication. So if you don't know, division and multiplication have the same priority when it comes to order of operations. So what it ends up doing is it ends up working from left to right. Uh, you know, when it comes to the order of operations. So it seems like this is what it wants: 1.0 divided by 2.0 times triangle base times triangle height output. So print triangle. So it wants this as a quote, but we're going to be adding in the variable. So we're going to do f string, and it wants a string that says triangle area is, and then followed by the value of we got to put that in brackets, curly brackets, triangle area. How did I put that in there? Oh, I meant to do underscore and it accidentally clicked that one. So triangle area to 5, we don't want to miss that again, to 5 digits after the decimal point. So let's double check it. So we created the variables triangle base and triangle height to read, to take an input or read a float number coming in. And then we did the calculation that it's saying that we need to do here. So triangle area, and then we're outputting it with 5 digits after the decimal point. So let's check it. What the heck? What did I do wrong? Oh my gosh. So as you can see, I put it outside of the curly brackets here, and that won't fly. It needs to be in the curly brackets after the variable. So okay, so then that corrected it, and it came out correct. Any questions? I still see a couple people in here, so that's awesome. That's I didn't see that yesterday, I don't think, so that's really awesome. If you have any questions, just put it on the chat. Is chat on? Yeah, let me test it. Okay, yeah, no, it's out. It's the chat is working, I think. So cool. Alrighty then. Okay, so on to 3.5. So where are we here? Rhythmic expressions, Python expressions. Basics for arithmetic expressions. An expression is a combination of items like variables, literals, operator, and parentheses to evaluate that evaluates to a value like 2 times x plus 1. So that's an expression. So commonplace. The common place where expressions are used is on the right side of the assignment statement, as in y is assigned 2 times x plus 1 with the braces or brackets, or I can't remember what this is called, being x plus 1, meaning this will calculate first and then 2 times whatever this number will be next. A literal is a specific value in code like 2. An operator is a symbol that performs a built-in calculations like addition or plus, which performs addition. Common program operators are shown below. So this is where I was saying earlier, where this was how you did the exponent. So like to the power of, oh, it even says it right here, to the power of. So easy here. Addition, of course, subtraction, the 2 lowest priorities, the multiplication operator, the division operator, which are both on equal priority, and the exponent operator, which is the two asterisk signs here. So x double asterisk y is the same as x to the power of y. These, I would recommend writing these down as a note. I think it's very important to understand what these do. Later, I believe it will teach us about the double forward slash, which is the what operation was that called? It is called, because I know the percentage is like modulos, and the other one is called something else. I wish I could remember. Dang. I will learn it later. Basically, it keeps digits to the left, and then the modulos, the percentage sign, will keep all the digits to the right. And I'm pretty sure we'll learn that later. I think we actually learned that in let's see. Well, I think phone number breakdown is a test on it, and we might learn it here somewhere. I don't know. Anyway, we'll keep going. But yeah, so anyway, we'll worry about that later. Okay. Indicate which are valid expressions. X and Y are variables. X plus 1 is valid. 2 times X minus Y is valid. Indicate which are valid expressions. This, because the X is alone, I feel like this could be interpreted as a variable versus an expression. So I'm going to say not valid. What? Oh, it can be just a variable. An expression can be just a variable. You know what? I'm going to write that shit down, because I would have thought, hey, what if it's confused? Because what if I did like X, right? And then X, I don't know, and then later on, like tried to call X. I don't know. I thought it would have been confusing, but because it's not, and because I was wrong, and I want to remember that, so an expression. Oh, I can't write with that pen. Where's my pen? Damn it. Okay, quick water break, and I'm gonna get my pen. BRB. Okay. So an expression can also be a variable. Just a variable. Okay. Now, this one's interesting, because if an expression can be just a variable alone, can an integer or a numeric number be? I would say yes. If a variable can, why can't a number, right? Why can't an integer? Okay, good. Be just a literal. Okay, so it's referred to as just a literal. 2x I mean, we see like, there's none up here, but you see 2x all the time, like 2x plus 3 and 2x plus 5. So, okay, in programming, multiplication typically must be indicated explicitly using okay, so this is kind of like saying 2 times, but it's thinking that 2x means 2 times, which I was not, but it could be confusing. Which is interesting that that's confusing, but not that, but whatever. So explicitly with the times operator, abutment is allowed in math, but not usually in programming. Interesting. 2 plus xy. I feel like that is a, why not? In programming. Because right here it tells us that abutment is allowed in math, but not in programming, but not usually in programming, and that's what this is doing, is it's abutted. So, but this y equals x plus 1 is valid. Oh no, because it's being assigned. Okay, so yeah, so x plus 1 alone is not an expression, but x equals x plus 1 is an assignment, not an expression. But if this was gone, then it would be an expression. But because this is y equals, that's an assignment, not an expression. I should have known that. I don't know why I clicked true or valid. Does the expression correctly capture the intended behavior? 6 plus num items. 6 plus num items. Does the expression correctly capture the intended behavior? I to me, the way I'm thinking of it is, if I were to see this, I would say no, because to me it looks like this is trying to be assigned, but at the same time they may be trying to print 6 plus number of items. So does the expression correctly capture the intended behavior? Possibly. I would say yes, maybe. Okay, so yeah. 6. See, the expression is straightforward addition. I get that. I think maybe I'm just reading too much into it, and that's why I'm confusing myself. Because, yeah, obviously it's a straightforward expression, but when you're thinking of it in programming, is it being assigned? Is it printed out? Is it, you know, part of a function? What is it, 6 times num items. So 6 times num items. Well, this is going to be no, because you don't say multiplication with an x. You use an asterisk. See? An asterisk. Total days divided by 12. Total days divided by 12. That's going to be a yes. 5 times t. 5t. It's abutted. We need an asterisk there. So this is going to be a no. The negative of user val. That's a great question. I've never seen a negative and then a variable name. So I want to say that this is not valid, but it is. See, I'm always wrong when I think it's not. Serves as subtraction. Okay, because it's not thinking of it as a negative. It's thinking of it as a subtraction. Okay, so it can see it as either a subtraction or a negation. So yeah, so it could work both ways then. So in factorial. Now I'm going to say no, because this is not a mathematical operator and it's abutted. So I'm going to say no. Python does not use the blump symbol for factorial. All right. Oh, these were, I think, yeah, these are the things I was telling you about. All right. An expression evaluates to a value which replaces the expression. Example, if x is 5, then x plus 1 evaluates to 6. And y equals x plus 1 assigns y with 6. An expression is evaluated using the order of standard mathematics and is also known as, in programming as the precedence rules. List below. So this is the order of operations that I was talking about, which takes precedence over the other. So the items within parentheses, that's what they're called. Sorry, I just realized I didn't know what it was called. All right, parentheses, items within parentheses are evaluated first. So here it gives an example. In 2 times x plus 1, the x plus 1 is evaluated first with the results then multiplied by 2 times whatever this answer is. The exponent, double asterisk, used for exponent is next. In x asterisk asterisk y, so x exponent y times 3, x to the power of y is computed first with the results then multiplied by 3. Unary, so minus sign here, or negative sign, used for negation, unary minus is next. In 2 times negative x, the negative x is computed first, with the result then multiplied by 2. Next to be evaluated are the times, the division, and the modulus having equal precedence. The modulus is discussed elsewhere. So this was the modulus that I was talking about earlier that will and this answered that what I was wondering is if I think we learn it further ahead, and we do. It tells us right here. I just forget what the double division sign means, forward slash. I forget the name of it. Excuse me. Finally, come plus and minus with equal precedence. In y equals 3 plus 2 times x, the 2 times x is evaluated first because says up here that it's next, or it has higher precedence than plus minus, with the result then added to 3 because times has higher precedence than plus. Spacing doesn't matter because y equals 3 plus 2x times x would still evaluate 2 times x first. Left to right. If more than one operator or equal precedence could be evaluated, evaluation occurs left to right. Note the exponent operator is evaluated from right to left. And y equals x times 2 divided by 3, then x times 2 is evaluated first with the result then divided by 3. So what I was saying earlier, it would evaluate our going from left to right. Oh my god, I don't know why I keep fucking yawning. Jeez. All right. Evaluating expressions. Expressions such as 3 times x plus 10. Items within the parentheses comes first. So these parentheses would go first. So it shows us here that the parentheses was evaluated first. And then in here, x plus 5 was evaluated first, bringing it down to 3 times 9. Y equals 27. Many programmers prefer to use parentheses to make order of evaluation more clear when the order is not obvious. So like doing it this way, it's preferred to do 3 times parentheses x plus parentheses 10 divided by w. I think it did. what did it do? Oh, okay, it uh, did the um, parentheses and 10 divided by W first and then second. So yeah, it's just kind of telling us what it did here as well. So, all right. Select the expression in which parentheses match the evaluation order of the original expression. Y plus 2 times Z. Okay, so that would be this one because we learned that multiplication has precedence over addition. 2 divided by, I'm sorry, Z divided by 2 minus X. So we learned that multiplication and division were took precedence over minus. So that's going to be this one. Because so x times y times z. So this is, uh, since it's both multiplication and multiplication does take precedence, then it's just going to work from left to right. So I'm going to choose this one. X plus 1 times y divided by 2. Now it explained to us that it will work from left to right if there's 2, right? So it would do 1 times y divided by 2. But it also showed us that the preferred method is this way right here. So let's see if there's a preferred method done. So and there is right here. So you do the parentheses around 1 y divided by 2, and then why is that wrong? I mean, it told us. Times as you value precedence and left to right. I mean, I did say left to right, but you also said that the preferred method is like this. So did you lie to me and now I'm wrong because you lied to me? So because it lied to me, that means it's going to be this one. Fucker. It's like you even put this here, you know? Oh, because the parentheses are right here. And addition does not take precedence over division, but with this one, it's multiplication division, so it would have worked too. That okay, okay, I was wrong. I was wrong. It was two different things. This one was addition. This one was multiplication, so it would be going from left to right. I was wrong. This was correct. I admit it. My bad. What is a total counter after executing the following? So num items is assigned 5. Total count is assigned 1 plus 2 times num items times 4. So this here is saying that we want to do 2 times 5, which is 10 first. So this is 10, and then we're going to do 10 times 4, which is 40, and then plus 1, which is 41. So I'm going to do 41. Which operator is evaluated first? Select one. So let's start. Which operator is evaluated first? The multiplication is. On this one, the division. Oh, no. Hold on here. Would the negative be evaluated first? Yeah, the unary. The unary would be evaluated first and then the division. So I feel like that was a trick question, and I'm going to say it's this. Yes. Which operator is evaluated first? So uh, we have multiplication and division. They're both of equal precedence, so that means it's going to work from left to right, so that means it should be the multiplication. So this one, we know that the unary takes precedence over the multiplication and addition, so I'm going to say the unary. Oh, nope, nope, because the I should have looked at that. The parentheses is actually the highest. So it's actually very first. So, is it not going to let me do it again to get the correct answer? Oh, you dick. Okay. Oh, it is. Okay. um, the multiplication. There we go. First will be the parentheses, so the minus. Excuse me. After the minus, it will be the multiplication. After the multiplication, it will be the addition. Boom. Moving on. Okay. Using parentheses to make the order of evaluation explicit. A common error is to omit parentheses and assume an incorrect order of evaluation, leading to a bug. Example, if x is 3, then 5 times x plus 1 might appear to evaluate as 5 times 3 plus 1, or 20, but actually evaluates 5 times 3 and then plus 1, or 16. Spacing doesn't matter. Good practice is to use parentheses to make order evaluation explicit, rather than relying on precedence rules, as in y equals m times x plus b, unless order doesn't matter, as in x plus y plus z. A website lists the calories expended by men and women during exercise as follows. Looks like that'll take us to a different site here, but men calories equals, and then it's got this long ass thing here. So age plus weight plus heart rate minus, excuse me. So, okay, below are those expressions written using programming notation. So calories man equals, and then age years times 0.207. Okay. Converting a formatted expression to a program expression. Consider the example above. Match the changes that were made. So the brackets, whoops, were replaced by the by these here. This here was replaced to equal that, and then let's see. I mean, is that? Yeah, okay. So that, and then underscores. So the underscores or the spacing. Yeah, perfect. Where are we here? Okay. Calculate the values of the integer expression. Type the program's output. So print y. So x is assigned 13, and y is assigned x, which is 13. So 13 plus 2, 13, 14, 15. 15. 13, 12, 11, 10, 9. 6 times 2, or 2 times 6 is 12, right? 6 times, is this 12 or 16? 16? Do I need to use my calculator? I suck at math, even simple math. It's embarrassing, honestly. 2 times 6 is 12. Yeah, I was right. Okay. Okay, so this is actually x to the power of 2. So 3 to the power of 2, I believe that means 3 times 3, right? So it would be 9, right? Yeah. Okay, so so x is 3. So 3 plus 8, so 8, 9, 10, 11, 11. So 2 times 11 is 22, right? Yeah, 22. What? Oh, dumbass. This is why you have to read and be detailed, is because you could easily just skip a step. So it's actually going to be print x and y. Oh, interesting. So x didn't change. Oh, whoops. X didn't change, never changed. So when it asked me to print x, I'm going to put 2 because it was never reassigned. And then 2 times 8 2 times 8 is 16. And then 3 times 16 is 48. So that's going to be 248. What? 2 plus 8 is 10. 8, 9, 10, right? 10. Oh, 30. That's why. I did my math wrong. Okay, let's try this again. I know the answer to x is 2. 2 plus 9. 9, 10, 11. That's 11. 3 times 11. 3 times 11 is 33. So that should be 33. X is 2, y is 33. Okay. So this one has double parentheses. So that means we'll want to do this one first. So 3 plus 3 is 6. And then 2 times 6 is 12. And then 12 plus 5, 12, 13, 14, 15, 16, 17. So 17. So 3, 17. Yes. Okay. Perfect. Da, 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 da. Quick water break. I love Python, but this is my least favorite part is doing math because even the simplest math I got to use my fingers on, or the simplest math will confuse me and I'll have to use a calculator. It's a good thing. Excuse me, I didn't mean to show you my uvula. Um, it's a good thing that, and I'll have to double check, but I believe when you go and take your assessment, they will allow you to have a scientific calculator. So I believe that it'll allow you, and I'll double check, and then on my live on Monday, continuing this, I'll let you know. But I believe you can use a scientific calculator when you take your assessment. So I got that handy and ready. Okay, let's continue. Python expressions. Arithmetic expressions. Below is a simple program that includes an expression involving integers. It computes the total cost of leasing a car given the down payment monthly rate. So it looks like it takes an input for down payment, for payment per month, and for a number of months. And then it will output the total cost, and then it will print total cost, and then whatever total cost is with 2 digits after the decimal. So like right here, the down payment is 500. The monthly payment is 300 and the number of months is 60. So the total cost would be 18,500. And then this right here, 2F, puts 2 digits past the decimal. Consider the example above. Would removing the parentheses as shown below yield the same result? So down payment plus payment. So here it does, okay, so it does payment times. So from what we learned before, it said it doesn't want you to rely on order of operations or precedence, right? However, the question is asking, would the result be the same? And it should be. Should we rely on it with like proper syntax, clean code? No, we should put the parentheses in. But for the sake of this question, I'm going to say yes, it would yield the same result. Would using two assignment statements as below have yielded the same result? Payment per month times this, total cost equals payment per month time. Would using two assignment statements as below yield same result? So all months cost is assigned payment per month times number of months. Total cost is assigned down payment plus all months cost. I'm going to say yes because it looks like number of months, all months cost, down payment, payment per month. Is it saying I'm going to say yes. Yeah, it's okay. So the evaluation is ultimately the same, yielding the same result. Breaking larger expression into multiple assignments with smaller expressions can sometimes improve code readability. But yeah, okay, that's fine. Style. Single space around operators. A good practice is to include a single space around operators for readability, as in num items plus 2, rather than num items no space plus no space 2. An exception is minus used as negative, as in x coordinate is assigned negative y coordinate. Minus used as negative is known as unary minus. Okay. I'm gonna write that down because uh, I mean before I didn't know it, but it's different for me because I didn't know that the negative and minus mean that. So negative. Okay. Retype each statement to follow the good practice of a single spacing around operators. Note, if an answer is marked wrong, something differs in the spacing, spelling, capitalization, etc. This activity emphasizes the importance of such details. Retype the statement to follow. So it's wanting us to retype the whole thing, right? So houses underscore city houses underscore block times 10. So the spacing after the 10, I'm sorry, the spacing after the multiplication here. Houses block, city houses. And this one, total equals num1 space plus space num2 space plus space 2. Num ball space assignment space num underscore ball space plus space 1. Oops, 1. Okay. So I'm just adding the spaces as it talked about, for having good practice. Num entries space equals space user val space plus 1 2, right? Oh, oops, I double spaced that space. There you go. Perfect. Okay. Special operators called compound operators provide a shorthand way and update a variable such as age uh, plus equal 1. So being shorthand for age equals age plus 1. Okay, so okay. Other compound operators. So we can write like, oh, here it shows us right here, age plus 1 instead of age equals, 1 plus 1. This addition assignment. So age equals age plus 1 is what it's saying. Same thing with subtraction, age minus 1. So age is the same thing as age equals age minus 1. Multiplication, division, modulo operator discussed elsewhere. What I was talking about earlier, assignment. Age modulo 1. So I think that's remainder 1, right? I think that's what that means. All right. Num atoms. Hello. Welcome. I hope I am helping you as study and learn as I go through this, because I think like talking out loud and going through this in my head with you kind of helps me too. So I hope you like it. Give a thumbs up, and then if you have any questions or want me to go through something else in this or through something else in Python on in regards to what we're doing here, then let me know and I'll be happy to help. Num atoms is initially 7. What is num atoms after? So num atoms is initially 7. So is it saying like, is there a way to turn this off? Right? Oh, so it's just going to do it. I have to click X every time. Num atoms is initially 7. So was it saying that num atoms, it was initially 7? So is it saying that, oh, okay. So now it's saying, what is num atoms after num atoms? So 7, 8, 9, 10, 11, 12. So I think it's going to add 7 plus 5. So I'm going to say 12. Yeah. Okay. So because same as num atoms is num atoms plus 5. So 7 is plus 5 is 12. Num atoms is initially 7. So 7. This is saying num atoms times num atoms is assigned num atoms times 2. So 7 times 2 is 14, right? Hooray! Rewrite the statement using a compound operator or type not possible. Okay, so car underscore count divided by equal 2. So basically, this is saying the same thing as car count is assigned car count divided by 2. That's what this is saying. Rewrite the statement using a compound operator or type not possible. This is not possible. I'm going to say not possible because when we do a compound operator like this, you're saying this is going to be assigned the same variable on this is going to be on the left and the right. So car count will be on both on the left and the right. So as a variable and then as a variable being divided by 2. Well, this won't work because if I did num items plus equals, box count, it just won't work. So I'm going to say not possible. A compound operator is shorthand for when a variable is updated, not for a more general assignment. So yeah, well stated. Commas are not allowed in an integer literal. So oh, this one's cool because you can actually use underscores to replace the commas. So you could actually in Python you can actually do 1_333 underscore 555, which would be the same thing as 1,333,000, and that's probably what it's going to teach us here. So we'll keep going, but are not allowed. So it actually takes this number is written as this right here. The following code correctly assigns num years with an integer value of 2 billion. This is false. I mean, it tells us right here that that's false. Commas are not allowed, but underscores are. And I'm assuming it hasn't gotten to that point yet. The area of a circle is calculated using the formula area equals r squared times pi, where r is the circle's radius. Given variable circle radius, read from input and constant pi, compute the area of a circle and assign circle area with the area. Okay. Given variable circle radius, read from input and constant pi. Compute the area of. So it's wanting us to take. Okay, so it's taking in. There's a float circle radius. Given the variable circle radius, read from input, okay, reading from input and constant pi, read from input and constant pi, compute the area of a circle and assign circle area. So circle area is Why am I not? See, this is what I was talking about before, where the math doesn't math in my head. So the area of a circle is calculated by using the formula. Okay. So given variables, circle radius, read from an input, read given variable circle radius read from input and constant pi, compute the area of a circle and assign circle area with the area. The area of a circle is calculated using the formula area equals r2 times pi, where r is the circle's radius. So does that mean circle radius uh, to the power of 2, right? Because that's how you write to the power of 2 is with the exponent here. And then times pi, right? And for good measure, I'm going to do this because here it says that area is equal to, and in parentheses it has R2. So here in parentheses, we're going to do the radius to the power of 2 and then times pi. And then this will print it out and it'll have 2 digits after the decimal point, right? So let's go ahead and check if I'm right. What did I do wrong? Oh, did I do capitalization? Oh, I did. It's in all caps. So that's another thing. You got to pay attention to the details because just because I did a lowercase, and so that's why. But let me make sure. Circle radius is spelt right. X to the power of 2. Okay, that should be right now. Okay, perfect. Okay, awesome. So, I mean, math is interesting when you finally get it right and you're like, oh, damn, that's right. But I think I prefer math in coding than I do in like actual like math like this in real life. So because I feel like even if you don't know how, or even if you don't know like math in your head, as long as you know the formula or how to solve it, like area equals R2 times, right? So then I could just use that same thing. And as long as you know the formula to solve it, you can, code it. So I think that's cool. Oh, I think I saw division and modulo. Woohoo! This is what I was talking about earlier, the double forward slash, and I kept forgetting the name of it. Oh, okay, so it's the floor division operator. That's the name of it. So I think this one's going to be fun. I like this one. This one to me earlier, I think it was yesterday, was just freaking. I did one of the practice tests, and if you go watch it, it's funny to watch me because I got stuck on it for like 10 minutes trying to figure out this simplest math, and it was ridiculous, but I finally got it. So, all right, the division operator performs division and returns a floating number. Example, 20 divided by 10 is 2.0, 50 divided by 50 is 1.0, so on and so forth. The floor division operator can be used to round down the result of a floating point division to the closest smaller whole number value. The resulting value is an integer type if both operands are integers. If either operand is a float, then a float is returned. 20 floor division 10 is 2. 50 floor division is 1. So we can see here that it is keeping the floor. The way I looked at it and thought of it was that the floor division is going to keep the number to the left. Whereas if this were a modulus, it would keep the 0 and get rid of the 0.2. The 2 point. But so we can see here it drops to 0 and is 2 is 1. 5 for division 10 is 0, so it dropped everything here. So 5 equals uh, 10 times 0 plus 5. So the result is 0, and the remainder, 5, is thrown away. 5.0 for division 2 is 2.0. For division, the second operand of the forward slash or forward slash forward slash or for division must never be 0 because division by 0 is mathematically undefined. So it'll throw an error because it can't divide by 5. I mean by 0, sorry. So welcome in. We're just going through this. If you guys want me to cover anything else, let me know, or if you're bored of me going through this in order. Because right now, just for those who got in here, right now I am going through the ZyBooks in order. Um, so what I plan on doing is finishing number 3 here, variables and expressions, and then starting to do practice tests. And then just kind of working back and forth like this, because the issue I ran into yesterday was when we got to the phone number part, we were doing things that we hadn't learned yet. So I thought going back and forth can help us learn. But if you have questions, or if you want me to do it a different way or explain it a different way, I can. Or if you're like, hey, I'm stuck on this on ZyBooks or the test, let me know and we can go through that as well. Um, I'm not here because I'm an expert. I'm here because I'm a student just like you and learning just like you. So you will laugh at me getting stuck on some of these simple math things. But we get through it, we learn it, we get it wrong, and we learn why we got it wrong. Therefore, we retain it and we can, grow. So if you have any questions or anything else we're moving along, just let me know. All right. Determine the result type error. If the program would terminate due to division by 0, if the answer is a floating point number, answer in the form pound pound, even if the answer is a whole number. What? Does that make sense? Determine the result. Oh, type error. It's saying to type error. I was thinking like type like as in what is that? Type error if the program would terminate due to dividing by 0. And then if the answer is a floating point number, answer in the form of a pound. Pound point pound. Even if the answer is a whole number. Okay, so what, 12 divided by 4? I mean, do I need a calculator for this? This is what I was talking about with simple math that I suck at, right? So this is going to be a whole number. So it's saying answer pound dot pound, even if the answer is a whole number. So this would come back with 3, a whole number. So, okay, so some division yields a floating point result. So you told me to put pound pound even if it's a whole number. Are you wanting me to do the whole number? Like that? Oh, so the pound was a placeholder. Do you see what I mean by I can be dumb on this sometimes? I mean, like hopefully hopefully I'm not the only one having the same issues. I probably am because I suck at this, but 5 divided by 10 should be just 2, right? So 2.0? No? What's 5 divided by 10? Oh, it's 0.5, dumbass. Because yeah, there we go. This would be 5.1. So that would be. Oh, I know this one. I feel like this is going to be 2. Is it going to have me do rounds the result down to the closest whole number? So does that mean it's going to be 2.0? Yeah, okay. Because it wants me to do it in this format, that's why. Even if it's using the floor division, it still wants me to output it in this, the way it says here. And then this is actually going to bring an error because you can't divide by 0. So this is going to bring out an error. Oh, I forgot to mention, don't forget to hit a thumbs up. And I'll be here, once we're done here, I'll be here back on Monday. But I'm doing this um, until about maybe 4 o'clock, 3:30, 4 o'clock Central Time. So I still have about 3 more hours. All right. Modulo with some breaks in between. The basic arithmetic operators include not just plus, minus, times, division, floor division, but also modulus or modulo. I think that's how you say it, modulo. The modulo operator evaluates the remainder of the division of two integers operands. Example, 23 modulo operator modulo. I'm just going to say modulo 10 is 3. Why is that? So if I do, okay, so if I do, let's say, and this may be wrong, but the way I was explaining it earlier was that the floor modulus is going to keep the digits to the left of the decimal point, where the modulo will keep the digits to the right of the decimal. So 23 divided by 10 is 2.3. So because it's a modulo, it's actually going to keep 3. So it'll be 0.3 or just 3. So is 3. So right here it says it. Examples, 9. So here, hold on. So here, 9 divided by 4 is, I'm sorry, 9 divided by 5 is 1.8. But I don't think I can do it that way because it doesn't look like reason. Since 9 equals 5 times 1 plus 4, the floor division 9, okay, so yeah, would yield 1. So the floor division results in 1, and the remainder is 4. Oh, is it because of the 1.8? Because 9 divided by 5 is 8. I'm sorry, 9 divided by 5 is 1.8. So is it reducing it? Is that what it's doing? Um, how in math you do like 4 times 2 is 8. Like what do you call it when you reduce it? I can't remember, but that's why. And then what is this one? 70 divided by 7 is 10. So it would be 0 because the modulo will keep everything to the right. So reason 70 floor division is 10 with remainder of 0, and it keeps, and since there's no remainder, 0 is the answer. Same thing here. 1 modulo is 1. Reason 1 floor division 2 is 0 with remainder of 1. So if I do 1 divided by 2, that's 0.5. So it rounded up is what it's doing. Right? Right? Yeah. Yeah. Uh, let's continue, and then we'll kind of learn that part here because we're going to need to know this. We're going to need to know the modulo and the floor division really good because not only in the assessment, but in the practice test as well, which is basically mirror to the assessment, we're going to be using these operators or right here in 29.6. We're going to be using these. And so if we don't know these that well, it's going to be very hard to do. Um, which you saw yesterday. Well, if you go watch it, which you will see in my video, yes, from yesterday, is that I struggled really hard with these. So I'm glad we're learning it today in depth more. The basic arithmetic. Oh, I already read this, right? Okay. Example using. Okay. The program below reads the number of minutes entered by a user right here. The program then converts the number of minutes to hours and minutes. So hours, minutes, remaining. Run the program, then modify the code to work in reverse. The user enters two numbers for hours and minutes, and the program outputs the total minutes. So, can I do that? Enter minutes. 12 minutes is 0 hours and 12 minutes. So 186 minutes. 186 minutes is 3 hours and 6 minutes. So let's break down what it's doing here. So minutes, so this one's easy. I mean, it's taking the input and it's converting the input into an integer. And then hours is taking that input, so like 186, and it's using the floor division by 60. So if I took 186 divided by 60, that would be 3.1. So in my mind, the answer to this is 3, right? So 3 hours. And then the remainder is going to be the remaining minutes. So 60, or hold on, 3, and now minutes is 3 hours, and the remainder of 60, or I'm sorry, 3 modulo 60, which is the remainder, right? So minutes remaining, and it says 6 minutes, but 3.1. So I'm wondering why it's 6 and not 1. That's my question. Does anybody know? Does anybody know that why? Because if you do 186 divided by 60, oh, you know what? Do I need to do? Yeah. What? Why? Why is it? Let me. Let's do some research here because I really want to understand the why. Okay. Because we're not gonna fully understand if we don't know the why. So let's do some research here. So let me look something up here. Bear with me one sec. I'm probably gonna be. I sometimes I get quiet when I type. So um, Okay, and I'm sorry. I really want to understand this, and this is what I do when it doesn't make sense in my head. I like to go back and I like to research the why, um, and I like to figure out what what the math is doing. So it says that the expression 186 modulus 60, so we used 186 here. So 186 modulus 60 calculates the remainder after the integer division. So 186, so the formula it's saying is 186 minus 3 times 60 equals 186 minus 80. Oh, is it? No. If you if this makes sense to you, feel free to type it in the chat, but I'm still struggling here. So uh, oh, okay, that's why. Okay, so when we do the math, oops, do the math, it is so one. So the number one represents a unit, right? So when we say, let me go up here. So when we say 186 divided by 60 calculates how many whole times, so 60 goes into 186, right? So the result is three, represents three full units. Um, so like six and six, right? So 6, 12, and then oops, 18. So 18, yeah. So 180. I think that's what it's saying. I think it's saying that when we do the math of 186 divided by 60, we get 3.1, and this 1 represents 1 unit, which is 60. So when we change it to the modulus, it's actually going to do the remainder, which is 6. So that's how I'm understanding it. I mean, I guess we'll figure it out as we go, but that's the way I'm understanding it. And I'm probably confusing you more, but we'll kind of go through it together as we go. So 186 equals 3 full units, which is hours, plus 6 units, which is minutes. So decimal minutes equals 0.1 times 60. Oh, so it's doing 0.1 times 60. So not only do you have to do like 280, okay, so I did 286, right? Let's see if we can figure out the time before I hit run on 286. So if we do 286 divided by 60, that's 4.766667, right? So we're going to just round that up to 8 and hope it's right. But so that tells me it will that the minutes, I'm sorry, the hours is 4, and then we'll do 0.7, I'm sorry, 0.8 since we're rounding up, times 60, which is 48. But oh, okay, so 48 minutes. So that would be 48 minutes, right? So let's see if I did it right. Let's see if I figured it out. 46 minutes. It rounded down, which is okay as long as we got close. That's what I said, right? 286 divided by 60 is 4 hours. Yeah, okay. So it did round it down, but that's okay. At least we're kind of figuring out how it's working. So that's how you do the math. Cool. All right. So that way we don't spend too much time on it. Determine the result. Type error if appropriate, Only literals appear in these expressions to focus attention on operators. Most practical expressions include variables. Okay, I don't know why it keeps doing that. I want to get rid of that. How can I get rid of this stupid thing? 50 modulus 2. So in my mind, we have to do 5 divided by 2 first, which results in 2.5. So then we got to take uh, 0.5 times 2, which is 1, right? So 1. No. 5 divided by 2 is 25 with no remainder. Oh, no remainder. So because the whole number is 1, not 1.0, it's going to be O. Let's try that again. 51 divided by 2 is 25.5. So 0.5 times 2, since we're using the modulus, or modulo, that's 1. Again, it's a whole number. It's not 1.0, so it's kind of like 1.0, but because of the modulo, it's going to keep everything to the right of the decimal, so we're going to say 0 again. What the fuck? Did I... 51 divided by 2 is 25.5. 0.5 times 2 is 1. 51 times 2, or I mean 51 divided by 2 is 25. What is the remainder? 25 times 2 is 50. So how many more makes 51? 1. Why is it so different? Like it feels very freaking different. Like I guess I'm not understanding why this feels contradictory to me. But so it's saying 25 even though it's 25.5, and I, you know, and then 25 times 2 is 50. How many more makes 51? 1. I, hmm. Does it feel wrong to you? I don't know. Okay, let's try it again. I mean, maybe so 5 divided by 3, 1.66, right? But up here it did the same thing and it ignored the remainder and said 1. And then it did 1 times the number on the right of the modulo. So 1 times 3 is 3. I didn't need to retype that, but I'm gonna put 3, but it just seems wrong to me. Yeah. So 5 divided by 3. Come on. 5 divided by 3 is 1.66, right? So that's what I said, 1. What is the remainder? That's and then it's saying to take 3 and multiply it by that. So 3 times 1 is 3. So how many more make 5? 2. How many more make 5? It keeps saying that. How many more make 5? So we need to make sure that it equals up to the 5. Like, what are you know, anyway, the answer is 2, but, or I mean, according to that. So let's see if we can do the same thing here. So 27 divided by 4 is 6.75, right? 6.75. So we're going to say 6 and ignore this 0.75 because that's what it did, right? And it did, what did it do? It did uh, 4 times 6, right? Which is 24. And then it said how many more until you get to 27. So 24, 25, 26, 27. So the remainder should be 3. Okay, I think we're getting it. I think we're getting it. This is why we're here. Okay, so the way I'm understanding it is we should be dividing 27 by 4, getting rid of what's after the decimal, and then taking 4 times what you got on the left of that decimal. And then whatever that equals to, uh, how many more, ones, I guess, does it take to equal the number on the left? That's the way I'm thinking of it in my head. But let's see. 596 divided by 10 is 59.6. Okay. So I'm going to ignore the 6 again. And we're going to do 10 times 59. And I know I probably don't need the calculator on that, but I'm going to do it anyway. 10 times 59, that's 590. So now I got to ask myself how many more units until I get to 596. In this case, it's 6, which is the remainder. Perfect. So I think we got it. I think we fucking got it. Okay. If my cursing is bothering, please let me know and I'll stop. Sometimes I just curse. Don't forget to like my live and thumbs it up. All right. Ooh, this one's interesting because now we have the parentheses taking precedence, right? So we're going to do 1 divided by 2, which is 0.5. Oh, and remember, the floor division will keep all the digits to the left, right? To the left of the decimal. In this case, 1 divided by 2 is 0.5. So that tells me this is going to try and do 100 modulo 0. But we can't do that because you can't divide by 0. So to me, this is going to throw an error. Yes. All right. I hope that makes sense for everybody. Sorry, I keep getting notifications. Enter the output of the integer. Okay. So we have x is assigned 18. So 18 divided by 4. I use a calculator a lot, you guys, so don't judge. So 8 divided by 4 is 4.5, which is a floating number. But let's take a look. Sweet. Okay. So this is going to be x is assigned 11. So 11 divided by 4 is 0.5. But because it's a floor modulus, it's actually going to be, because the answer is 0.25, but because of the floor division, and I think I said floor modulus, and I'm sorry, but because of the floor division, we are going to get rid of everything to the right of the decimal, and so it should be 0, right? No, nope, I just realized I did the math wrong. I accidentally only did 1, not 11. So 11 divided by 4 is 2.75. So this is actually going to be 2. Okay. The floor division operator divides two numbers and rounds the result down. Okay, so it rounds it down. Remember before I was wondering if it'll round up, but it rounds it down to the nearest whole number value. And in my head, it's basically saying, hey, this is keeping everything to the left. That's what that tells me. Okay, so here's the modulo one. So let's see if we can figure that out. So x is assigned 7. So we'll do 7 divided by 3. and that is 2.3, right? And what we did before was we kept everything to the left of the decimal, which was 2. And then from there, we took what was the integer that was on the right of the modulo, which is 3, and timesed it by that number that we got from the division. So 3 times 2 is 6. So this should equal 1 because x is 7. So now we have to say, okay, the 3 times 2 is 6. How many more units until we get to 7? We only need 1. So this should be 1. Oh, come on. Oh, I forgot to hit the return button. That's why. It wants you to put in an enter like that. And I believe the practice labs and the actual test, when you go and do that, it's going to want the same thing, I believe. But just keep that in mind. So it wants it as a return. Did it change the number? I don't think it changed, just in case. 7 divided by 3. 3 times 10. Yeah, okay. So it should still be the same. Perfect. So, okay. So I think we figured out floor division and modulo then. I think we figured that out. And when we go into the practice test, we'll figure out if we learned something or not. So, okay. Let's go. Modulo. Is that like close to a beer? Anyway, modulo has several useful applications. Below are just a few. Given a number, modulo and floor division can be used to get each digit. For a 3-digit number, user underscore val like 927. So ones digit. So user val modulo 10. Example, 927 modulo 10 is 7. Okay, and just for kicks, we're going to take that example and we're going to do the math just to make sure that we understand, we know how this math right here is mathing. So the example it used was 927 modulo 10. So we're going to do 927 divided by 10, which is 92.7. Basically, we're just going to discard the 0.7. We're going to keep 92. And then we're going to do 10 times 92. That's 920. So how many more units from 920 do we need to get to 927? So how many remainder numbers is there? And it is 7. So it's 7. So I feel like we're getting a really good grasp on this. So temp val is val, so modulo 10, or user val, I mean. Perfect. Okay, so these are just showing some of the examples here. 97 divided by 4 modulo. So this one's saying is 92, then 92 modulo 10 is 2, right? And I think, yeah, 92. So that's what we got last time as well. So perfect. All right, let's move on. Given a 10-digit phone number stored as an integer, modulo and floor division can be used to get any part, such as prefix for phone number or for phone underscore num. Oh, see, it's going to start teaching us this part right here. Where did that go? Right here. So, given a 10-digit phone number stored as an integer, modulo and floor division can be used to get any part, such as the prefix for phone number or for phone underscore num equals 93655511212, whose prefix is 555. Temporary value or temp value or TMP val equals phone num. So the phone num is going to be this number here, and then modulo floor division 1, 1, 2, 3, 4. So is that, what is that, 10,000? So 10,000 this 10,000 removes rightmost digits. So 93655512121 divided by 10,000 is 936555 dot. So dot because it removes everything over here, correct? So, and then the prefix num is temp val modulo 1000. Modulo 1000 gets rightmost 3 digits, so 9365555 modulo 1000 is the 5. So what I think, and we're going to figure this out together, but what I think is happening is, you see how, and this is the simplest way I can think of it, okay? You see how we have 1, 2, 3, 4, so let's pretend the decimal's at the end here, right? 1, 2, 3, 4. 4 zeros. So right before the 1, that's 4 zeros. And that means that the decimal moved over to the left 4 times, right? So 1, 2, 3, 4. And I think that's how it's getting the numbers. So if we're looking at the phone number and we go from the left and say 1, 2, 3, 4, yeah, see? So that equals the answer here. And so what I think it's doing, and I think it's doing the same thing with the modulo. So with the modulo, we have 1, 2, 3 decimal points that this goes over right before the 1. And if we look at the phone number and we go 1, 2, 3, because it actually took this number. So where the decimal left off here, it's actually 1, 2, 3. So then it keeps the 555. So yeah, so I think that's what it's doing, but we'll figure it out once, as we move along. So dividing by a power of 10 removes rightmost digits. Example, 321. So it should be 32. Floor modulo 10 is 32. 32. Example, 321 modulo 100 is 3 because it moved it over 3 decimals. And remember what I said, that the floor division, the 2 forward slices here, front uh, forward slashes, so the floor division will keep everything to the left of the decimal. So because we move the decimal over twice, 3 keeps 3. And then the modulo will keep everything to the right. So kind of like right here, it had us move it 3 decimals over and it kept everything to the right. That's the easiest way I can think of it, is that floor division keeps to the left, modulo keeps to the right of the decimal. Okay, so write that down if that helps, but I'm like 99% sure that's what it's doing. And according to how it's showing us here, that's exactly what it's doing. But this is using the floor division as an example. So like we got the 32 and the 3. So now modulo by a power of 10 gets the rightmost digits. So 321 modulo 10 is 1 because 10, there's only 1 0. This is the way I think of it, is however many zeros there are is how many decimals you're going to move to the left, okay, from wherever the decimal started, or not started, but is currently at. Because this one here, we went from the decimal being here to the decimal being here. So 321, 1, so it wants us to move it over 1. It keeps everything to the right, so the answer is 1. 321 by 100, it moves the decimals twice to the left. Modulo keeps everything to the right, so the answer is 21. I hope that makes sense. If not, let me know. Okay, water break. One sec here. So after this here, I'm gonna take a quick break, like 2 minutes. Is 2 minutes too long? Is 3 minutes too long? If you prefer a specific amount of time as a break, let me know, because I don't want to like be selfish and come back and continue without you if you're actually like going through this with me and learning. So, but if nobody chats in the chat, then I'll do like 2-3 minutes. I'm sorry, 1 second here. Bear with me one moment, please. Sorry about that. 1 sec here. I just need to send this off real quick. Okay. All right. Sorry about that. Okay. Given a non-negative, given a non-negative number x, which expression has the range of 5 to 10? The range of 5. The range of 5 to 10. Um, given a non-negative number x, which expression has the range of 5 to 10? I'll be honest, I'm not sure what that question even means. Given a non-negative number, so x, so like what, 3, um, which expression has the range of 5? So is it saying this is the range here? I'm going to say this. No. Okay. So x modulo 5 yields 0 to 4, not 5 to 10. Oh, okay. So so x modulo 6 plus 5. I'll be honest with you, I'm not sure what it was talking about there, but x modulo 6 yields 0 to 5, then plus 5 yields 5 to 10. Oh, is it saying that 0 to 5? So it's saying that x? No, I guess I don't understand that part. Yeah, I don't think I understand this question and what it means or how this answer works, because what has the range? So x modulo 6 yields 0 to 5. So what does that mean, yields 0 to 5? Is it saying that this number could be anywhere from 0 to 5, right before 6? Is that what it's saying? Given a non-negative number x, which expression has a range -10 to 10? So is it saying that with the 20, that because, oh no, see, I'm already wrong. So x20 yields 0 to 19, then 0 to 10, then minus 10 yields 10 to 9, not 10 to 10. Okay. X modulo 21 yields 0 to 20, then -10 yields -10 to 10. Man, why is this part confusing me? So And if you know the answer, let me know. Which expression gets the tens digit of x? Example, if x equals 693, which expression yields 9? So if we do like, let's say we do 693, let's say divided by 100, right? Divided by 100, that's 6.93. And then we take 93, I'm sorry, we take 100, oh shoot, 693 divided by 100, 6. So the answer we need is 6. So 100 times 6, so 100 times 6, that's 600. So that's not right. But if we do 693 divided by 10, the answer is 69. So we'll do 10 times 69. That's 690. Okay. One more time. That's 693 divided by 10. So that's 69. So then 69 divided by 10 equals 6.9, so 6, and then 10 times 6, that's 60. That doesn't make sense either. That doesn't make sense either. Yields 9, right? 693 divided by 100. It's 600. Let's choose this one here. Yeah, so x modulo 100 gets the rightmost two digits. Example, 693 modulo 100 is 93. Oops, 693. You know what? I wonder if 693 divided by 100, right? So, and then 100 times, oh shit, I forgot what the number was. 693 divided by 100. So the 6 from what we learned before will take, so the answer is 6.93, but we're supposed to keep the 6, right? And so from what we learned before, we would take the 100 and times it by 6, and that would be 600. But this says 93. So I'm thinking that it reduces that 600 down to 93, like as in the smallest number. Let's do this. This is, so x 4 modulus 10 removes the rightmost digits, putting the tens digits in the ones place. Then modulo 10 gets the new ones digit, 693 modulus 10 is 69. So let's do the math with it here. So 693 divided by 10 equals 69 because the answer is 69.3. Then 69 divided by 10 is 6.9, but we want 6. So 10 times 6 equals 60. Oh, okay. And then the remainder is 9. Okay, that is making more sense to me now. I think with these up here, I think I was forgetting that step. So let's try this one here. So given a 16-digit credit card number stored in excuse me, given a 16-digit credit card number stored in X, which expression gets the rightmost 4 digits? Assume the fourth digit from the right is non-zero. Given 16-digit credit card number stored in X, which expression gets the rightmost 4 digits? 1, 2, 3, 4. So the modulo, because the modulo will get everything from the right. Right, to the right of the decimal. And these zeros is saying we'll go 1, 2, 3, 4, just like it's saying here. So the answer is this one. Uh, um, integers total zinnias and num zinnias, I don't even know what that word is, are read from input. A bouquet consists of number zinnias. So zinnias is a flower. And the number of zinnias is given by total zinnias. Total zinnias. Assign remaining zinnias with the remaining zinnias after making as many bouquets as possible. So is it saying, so it's saying that we want to do remaining, so it wants us to do the variable remaining zinnias, zinnias. Okay, so with the remaining zinnias after making as many bouquets as. So are we saying integers total zinnias and num zinnias are read from an input? A bouquet consists of num zinnias, and the number of zinnias is given by total zinnias. Assign remaining zinnias with the remaining zinnias after making as many bouquets as possible. So is it saying that we need total zinnias, floor module, num zinnias, right? Right? And then the remainder, and then the remainder of total zinnias, total, like that, because it's going to take, like, let's say we did like 50 and 20 or 55 and 20 or something, right? And then from there we would do the division on that and then figure out the remainder, right? So let's try that and see if that works. Let's make sure I spelt it right. So remaining zinnias, total zinnias, sorry. I'm just gonna yawn all day and I don't know why. Num zinnias. Okay, so I think I am good. So let's see if that's even right. So it's not. So let's figure out why. So remaining zinnias 2, expected output 0, so input 10. So so it took the input. Let's see. Let's do the math to figure out what it did. Because it took the input of 10 and 5, right? So I'm going to say 10 divided by 5 equals 2. And then we want to do it's 2, right? So then we would do 5 times 2, that's 10. So 0. So then my math should be right then. Is it, do I need to do it this way maybe? Let's see if maybe I need to put this in parentheses, right? So it'll calculate total zinnias first, floor module. So it'll calculate this first, and then it'll, whoops, and then it'll do total remainder. No, why am I wrong on this? To find the zinnias remaining after making as many bouquets as possible, the modulo operator is used. So is it saying that it wants, so is it saying that it wants the modulo instead of the modulo? Oh, that's what it was. Okay, so the modulo is figuring out the remainder. That's why. I was, so that means I was using the floor division incorrectly on that one. Let's continue. Integer input num is read from input. Assume input num is greater than 1000 and less than, assign 10 digits with input num's tens place value. Integer input num is read from input. Assume so assign tens digit with input num's tens place value. So tens place, so that's 0, right? So 1's tens, right? So let's actually, yeah, let's check that. And I'm wrong. So input, so value tens place. So is it because it needs an extra 0? But that's 1's tens hundreds though. I mean, is there an invisible 0 or something like after this or something? Dividing a number by 10 using floor division shifts the number right by 1 digit. Right? So does that mean it shifts 1, 2, 3? Oh, is that why? Because it shifts it right? Putting the tens digit in the ones place. So that's 4. Applying modulo 10 on a number gets the rightmost digit from the number. To find the digit in the tens place after of a number x is divided by 10 using modulo floor division, and then applied with modulo 10. For example, for input 18594, input num is assigned with 18594. Then 18594 floor division 10 is 1859. Finally, 1859 modulo 10 equals 9. So is it saying that it wants me to take the input and then I mean, because technically I think I could do it like that and it'll still move the decimal over if it's moving it to the right, but I don't think it is. So because that input put the 8 here, right? So that means it moved the decimal 1, 2, 3 over, and that's why it's 18, but it's looking for 9. So is it saying that it wants me to do floor modulo 10 and then, I'm sorry, floor division 10 and then modulo, no, because that can't be right. What the hell? Divided by 10, so, oh, okay. I mean, so then would it be still modulo 10 then? So basically what I'm telling it to do is to solve this, get the digits to the left of the decimal, and then do this to, I'm sorry, whatever that answer is, this times that answer, move it to the right. Let's check this because this is kind of confusing me. Oh, okay, so that's what it did want. So it was wanting the everything from the tens place. So it's interesting because here it says that dividing a number by 10 using floor division shifts the number right by 1 digit, putting the tens digit in the ones place. So that's interesting that it says it that way, because putting this to the one place, applying, because the one place is here, so it does not, I mean, dividing a number by 10 using shifts the number right by 1 digit. For example, 18594 input is assigned with 18594, then 18594 modulo 10 is, oh, is 18, okay, so, okay, so it basically took 18594 divided by 10, and it does put out 1859.4. So we'll take the numbers to the left, 1859, and we'll take 10 times 1859, and that will give us 1859. Oh, so that would give us 10 times 1859. Oh no, and that would give us 1859. And then we have to take 1859 divided by 10 again, which is 185.9, and then the modulo takes that number to the right of the decimal, which is 9. Okay, that makes more sense. Hopefully that makes sense to you. If it doesn't, let me know. But before we move on, I am going to take a break, so I will be back. All right, I think a couple minute break is fine. Let's do this damn thing. Here, I want to make a video for my TikTok. See if I can get more people interested in learning Python. If they want, I mean, whatever. If they want, just make a little cool video here. Yo, what up, dog? All right, I am back. I think a 2 minute break was fine for me. I hope you guys are back. Um, So let's keep going. Again, if you're new, I am just going through the ZyBooks here, currently on 3.8. And then once we get to the end, we'll do a complete um, practice test if we have time, because I am here until close to 4, so about 2 more hours. But if you wanted to go through anything else or you have questions, let me know, and I'll be happy to go through that. So, okay. Um, all right. So modules. So the interactive Python interpreter allows the programmer to execute one line of code at a time. This method of programming is mostly used for very short programs or for practicing the language syntax. Instead, programmers typically write Python program code in a file called a script and execute the code by passing the script as input to the Python interpreter. So let's do start. Programmer writes code in a script file named print underscore name Python. Okay. Python print name Python. Hi, Larry David. So it's just saying how from I believe a terminal you can say run my Python script. The Python script name or the file name is print underscore Python. And in this file is this script. So first name, last name, and then it prints it out. So when you say, "Hey, run my Python file," and it comes back as "Hi, Larry David." Programmers often write code in more than just a single script file. Collections of logically related code can be stored in separate files and imported for use into a script that requires that code. A module is a file containing Python code that can be used by other modules or scripts. A module is made available for use via the import statement. Once a module is imported, any object defined in that module can be accessed using dot notation. Example, a variable speed of light defined in universe.py is accessed via universe.speed of light. Okay, pretty simple. So here's the Python file, the script file. Import names, which is the name of this file, so names.py, so import names. And then this print here is accessing this names file here dot first, which says, okay, I want to access this file named name. Ugh, and then I want it to print the variable first. Okay. Same thing with last. Hi, Larry David. This end equals quotes here basically says to put so if you print these two without this end equals quotes here, it'll put these on two separate lines. It's pretty much saying I want this print line and this print line to be on the same line, and that's what it does here. What did I do? Oh, here we go. Separating code into different modules makes management of larger programs simpler. For example, a simple Tetris-like game might have a module for input, buttons.py, a module for descriptions of each piece shape, pieces, a module for score management, score, etc. The Python standard library discussed elsewhere is a collection of useful pre-installed modules. Modules also become more useful when dealing with topics such as functions and classes, where the logical boundaries of what code should be contained within a module is more obvious. Okay, so a file containing Python code that is passed as input to the interpreter, that's the file itself is called a module. Nope. Oh, I'm sorry. The file containing Python code that is passed, so it's script. uh, the Python code is called script. So a file containing Python code that is imported by a script is a module. Used to reference an object in an imported module. So you have to do the file name dot and then the variable name and then import in order to execute the content. So in order to search a script or that file, you have to import the names. So kind of like it shows here, you have to import names, import the file. And it doesn't have to be names, it could be anything. But, excuse me. When a module is imported, all code in the module is immediately executed. Python programs often use the built-in special name underscore name underscore to import if the file was executed as a script by the programmer or imported by another module. If the value of underscore name underscore is the string underscore main underscore with the quotes, then the file was executed as a script. In the figure below, two files are provided. Pet names initializes some variables, and favorite pet imports pet names.py as a module and uses some of the variable values to write a message. Running pet names.py as a script, so Python pet names.py, causes the code within the if underscore name underscore is equal to underscore main underscore block to execute, which prints some pet statistics when favorite pet.py is run and pet names py is imported as a module. The pet statistics are not printed. The if construct used in the program below is discussed elsewhere. For now, know that the code intended below the if name equal to name block only executes when the file is passed to the interpreter directly. So meaning not imported, like using import, right? checking if a file was executed as script. So if underscore name underscore is equal to quote underscore name underscore quote, Python pet names dot py, initializing pet variables, pet1 blah, Python favorite dot py, initializing pet variables, my favorite pet. So executes only if file run as a script. Example, Python pet names py. Import pet names. Importing the module executes the module contents. So import pet names. Pet1 pet name was born. Pet1 pet name. Okay. Importing module executes the whole contents. Executes only if file run as a script. So basically what here it's saying import names means that it will execute, so it executes all the content in the file, whereas if you use this here, it'll only execute what you ask for. So like pet name, pet1, or I'm sorry, accessing pet variable here, right? What is the output when running the following commands? Assume valid input of 10 is provided to the program. If required, if no output is generated, select no output. Note, the math module imported in fall, right there, provides functions for advanced math operations and is discussed in more detail elsewhere. So Python constants .py, gravitational constant. So for various planets. So if underscore name underscores, okay, print Earth contains Earth underscore G. Yeah. I think it's this one here. Since constants pi is passed to the Python interpreter, the value of underscore name underscore is and the print statements are executed. Python fall time pi. So import constants, import math. So according to above, this route only grabbed what it needed, but with the import of constants, it means it is importing the entire script. So this is going to say height, integer input, height meters, right? So I want to say no output, because if you import it, I don't think you need this, right? Is that what it was saying? See, I'm incorrect. It would be this one. Since fall time is passed into Python interpreter, the value of name is underscore name, and the print statements are executed. Okay. So I guess is it saying that it's just accessed different ways is what it seems like. I don't know. Let's not waste too much time on it. Okay, what are we on here? Math module. Random numbers, text, blah, blah, blah. And then we'll do some labs. Maybe I should have taken a longer break. Let's see here. Oh, okay. So it's going to teach us some of the math inputs, different math things like seal, which I believe is, I think you can use seal for rounding, like rounding up, rounding down, power of, or the power, yeah, the power of, and then square root, ceiling. I believe that's what that stands for. For meaning round down, round up. I think that's what that means. So yeah, round up, and then floor. Where's floor? Round up. Oh, right here. Round down. So that's what that means. Okay. So this is basically showing you then advanced math stuff. So that's cool. All right. So while basic math operators like plus or times are sufficient for some computations, programmers sometimes wish to perform more advanced math operations such as computing a square root. Python comes with a standard math module to support such advanced math operations. Excuse me. A module is Python code located in another file. The programmer can import the module for use in their own file or in an interactive interpreter. The programmer first imports the module to the top of the file. So kind of what it was showing us before is you're going to import it. So you're going to say import math, right? Oh, like right here. And in order to call that, you kind of like it was showing us before, you have to call for the file. So math dot and then whatever math you want to use, like floor, square root, or things like that. The math module provides a number of theoretic, trigonometric, and logarithmic operations uh, that a programmer may use. A mathematical operation provided by the math module can be used as follows. Importing the math module and calling a math module function. So import math, num equals 40, or num is assigned 49, num square root equals math square root num. So it's grabbing, or it's saying what's the square root of 49. Square root is known as a function. A function is a list of statements that can be executed simply by referring to the function's name. The statements of square root are within the math module itself and are not relevant to the programmer. The programmer provides a value to the function like num above. The function executes its statement and returns the computed value. The square root num above will evaluate to 7.0. The process of invoking a function is referred to as a function call. The item passed to a function is referred to as an argument. Some functions have multiple arguments, such as the function pow or power b, comma e, which returns b square root e, or b to the power of e. So how we were using exponents before, is same thing. The statement 10 generation ancestors is assigned 1024 times number of people could be replaced by 10 generation ancestors is assigned math.power to 10 times number of people to be more clear. 1024 times number of people could be replaced by math.2 power 10. Example of using math functions, savings, interest. Okay, so import math, base, float, interest. Okay, so let's run this. Enter initial value. So enter annual rate, percentage rate, savings after 20 years. So it's taking these input. So it's taking the inputs and then it takes the total. So it's base times, and then it calls for math, the function math. I'm sorry, the module math, and uses the power function 1 plus rate divided by 100 years, which is the variable here. Nice. Okay. Commonly used functions from the math module are listed below. Has a complete listing. So what I want to do is, okay, that's fine. We'll continue here. So these are some of the functions. If you can, or if you want, take a screenshot of that. It'll be useful later on. But I think these are going to be important to know if you're doing the exam, if you're part of this class and doing the exam or the assessment, you're going to want to know this stuff too. So, but we'll continue on. All right, determine the final value of z. So x is assigned 2.3, z is assigned, and so here it's calling for the math module, and it's using the ceiling function. Ceiling function will round up. So it's saying ceiling x. So it's telling x to basically be rounded up. So this will be 3. And then x is assigned 23, or I'm sorry, 2.3. Z is assigned, and it's calling for the math module again using the floor function, which rounds down. So this will be 2. Welcome in. If you want me to do something else or go through something else on this, let me know, and we can do that. Otherwise, I'm just going in order of the ZyBooks here, going in order. And right now we're on 3.9 math module. Let's see. Z is assigned 4.5. Z is assigned math, and then it's using the power function. So math, and then again calling for the math module using the floor. So round down. So 4.5 rounded down. How does, so raise x to the power of y. So this is saying 4 to the power of 2, right? I think that is 2, right? 2. Oh, it's 4? Oh, because it's 2 times 2, so it's 4. Yeah, whoop, my bad. No. Yeah, 4. Return 4. Bro, that's what I'm saying. Oh, no. What the hell? 4. Oh, it's stupid. So 4 to the power of 2. So 8? No. 8? No. 16 or 12. Watch. So 4, 8. It's got to be 8 then. How do you figure out? How do you figure that out then? So it's 4 times 4. Oh, 4 times 4, which is 16. That's what it is. Okay. Or 16.0, whatever. Return 16. Because what it's saying here basically is it's calling for the power, right? Power function. And then it is using the floor function to round z down to 4. So now it's saying 4 to the power of 2, and 4 times 4 is 16. Z is assigned 15.75. Z is assigned, so right here it's using the square root function, and it's using the ceiling function within it here to round 15.75 up. So this is going to be 16. So the square root of 16 is 4, right? Am I doing that math right? Yeah. And then here, z is assigned 4, factorial. So factorial, actually, I'm going to take a screenshot of this myself because I want to be able to refer to this, use it as a cheat sheet later on. Excuse me. So what is factorial? So factorial is 3 is not equal to 3. Is that what that means? Times 2 times 1? So is it saying I actually don't know. I'm gonna research this like we did before, so this way we can understand how it's working. Uh, and yeah. So this way we can understand it. So what I want to see is like, how is factorial function working? Because if we know how it's working, then we'll know what it's doing when it takes in a variable or um, so so it's saying you like if you input the argument 4, which is z, you start with 4 and multiply it by every whole number down to 1. So factorial 4 equals uh, 4 times 3 times 2 times 1. So 4 times 3 is 12, and then 12 times 2 is 24, and then 24 times 1 is 24. Oh, interesting. Okay, sweet. Okay, so it even shows here. So 4 times 3 times. So does that mean if it was 6, it would be 6 times 5 times 4 times 3? You know what I mean? I'm just checking to see if I'm right on that. So yeah, so you would do 14, like if it was 14 here, you would do 14 times 13 times 12 times. So yeah, so you would definitely do that. Okay. Import math. All right. So x is assigned with the square root of 4, which I believe is 2, correct? And it wants us to do a float. So the square root of 25 um, is what is it? Um, Square root of 25 is, I want to say, like, it's 5 times 5, right? So it's 5, right? I keep forgetting the point oh. 49 7.0. Bear with me one sec here. Okay, I think my, oh, I thought my ear set died, but I don't know. Is it still on my ear set? It won't show me. So let me see. Headset, I mean. Um, oh, it doesn't even show me. Yeah, it doesn't show me if it's on this headset. Well, we're gonna go through a little bit longer anyway. I may cut it short here, but yeah, I'm gonna cut it short on this one. So I'm gonna finish this one and cut it short. Um, but let's continue. So fabs. Okay, so what does fabs do? So let's take a look at this cheat sheet here. So fabs is absolute value. So what is the absolute value of negative 8.9? I don't know how to figure out uh, that. So let's do some research. Excuse me. So the absolute value. So is it saying that an absolute value is non-negative number? So instead, so it's just going to be 8.9? Is that what it's saying? Let's see. Ah, yeah. Okay. No, 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 don't jump. Sorry. Math. Okay. So power. So that means it's going to be 2.0 to the power of 3.0. So that would be, let me do some math on the calculator. So that would be power, so 2.0 to the power of 2.0. Oops, sorry, I keep pressing the wrong button on the stupid calculator. So that means it's 2.0 times 2.0 times 2.0. So that will be 8.0. 8.0 function takes two arguments as an input value, raises 2.0 to the power of 3. So basically 2.0 times 2.0 times 2.0. That's what that means. Next. Okay. Fabs, the absolute value plus 12. So is it saying 15 plus 12, which is what, 27? Point 20, come on, number 2. 27.0, right? So 15 plus 12, that's 27, 5, 6, 7, yeah, 27. So let's see. No? Oh, expected 3.0. Let me see. I want to figure out how I did the math wrong on that. I mean, obviously I did it wrong, but I want to know why or how. So this way I can learn and figure out how to do math. So it looks like you need to do, so you need to do 15 minus 15.0 plus 12.0, which is negative 3.0. And then, oh, and then you take that and you drop the negative to make it the absolute value, right? So yeah, so okay, that makes sense. So with this one, if I'm understanding correct, you do like negative 8.0 plus 2.0. Oops, I did the calculator wrong again. So you would do negative 8.0 plus 2.0, which is 6.0, and then you drop the negative. So this should be 6.0, right? Yes. Last one. Power. 2.0 to the power of whatever the square root of 9 is, right? So the square root of 9 is 3? 3? What's the square root of 9? That's not right. Hold on, I'm mathing. So it's 3. 3. I don't know what I said. Did I say 3? I don't know. Anyway, so that means you're taking 2 to the power of 3, so 2, 4, 6, so it should be 6.0, right? 8. Why 8? Uh, let me see. Because you want to take 2.0 to the power of 3.0, right? To the power of 3.0, because the square root of 9.0 is 3, right? So what do you want to do? You want to do 2.0 times 2.0. Oh, 2, 4, 6, right? 2 times 2 is 4. 4 times 2 times 2 equals 4 times 2 equals 8. Oh my gosh, I don't know what I was thinking. What was I thinking? Addition, probably. So 8.0 is what that should have been. So 5 times 5 is 10, 15. So it'd be 15.0, right? What the fuck? That's it. I'm using a calculator. I'm not trying to do it in my head now. So, um, Square root of 4 is 2, so 3.0 times 3.09. Okay. Jesus. Okay. I know I'm leaving earlier than I said, but I guess I said I was getting off between 3 and 4, so I guess I'm getting off on time. But all right. Well, I hope you like this. If you didn't, then I'm sorry, but it's mainly, for teaching me and those who learn like me, kind of like a group study. So if you want to see me do something else on Monday, or you have questions over the weekend, let me know and I can answer them, or I can do my best. And then we'll just kind of go from there. So thanks a lot, you guys. Later.